In this lecture, we will discuss about the loads. In the last class, we have discussed different classifications of structure. So load is very much important in the structure analysis. So we'll discuss what the different types of loads are available and how to take care of all the loads. So if you see right side here, a building or a structure is there. You see how many loads are acting. Maybe this structure is situated near to the Himalayan region. So you can see that snow load is coming here. So this one is your snow. Snow load is also kept coming into the roof. So this is also adding the extra load in a structure. Now, if you see the structure itself has some weight, right? So this is a slab is coming. This structure is consist of this slab, and then you have beam here, and then you have column. So each member has its own weight. So for example, slab is made up of concrete, or maybe here it is made up of some steel material or something, plywood or anything. So this material also has some load. So that actually we call it dead load. So classification of loads, these are the different types of classifications. So first one is dead load. What is dead load? Dead load is the load of the structure itself. That is, we call it self weight of the structure is dead load. Now what is live load? Live load means as we will stay here, so we are actually live, right? This is the live load. So our load when we are inside the room, so our load will be live load. Similarly, you have bed, table, TVs, fridge, everything, whichever is movable inside the house, all are actually the live load. So live load means which can move, or if we can move, or which are not fixed, so that we call it live load. Then next we have third category is wind load. So see, some structures are situated in a top of the hill, so in that case the structure is also experienced to horizontal force, that is we call it wind load. So please remember, see the self weight of the structure or the first dead load is always vertically down, because of gravity, all the load, all the material will be pulling towards the down. So that's why dead load is vertical. Now similarly, live load is also maximum k time, it is vertical load. And wind load is actually horizontal, because wind is blowing in a horizontal direction, so these are horizontal load is a wind load. Next, snow load. Snow load is obviously, it is also a vertical load, it is acting load vertically. Then next we have is earthquake load. So during the time of earthquake, maybe in South India earthquakes are frequently less, but if you visit Himalayan region like Northeast or maybe Nepal, Bihar, UP, in that region, so in that regions are experiencing earthquake load very frequently. So that load we call it earthquake. So due to earthquake, our structure experiences extra load, so that we call it earthquake load. And then we have hydrostatic and soil pressure. So in a retaining wall or some other location, you will find that because of the soil pressure, your structure is experiencing more load. So that we call it soil pressure or hydrostatic pressure. And then obviously thermal and other effects are also there, which also causes the extra load in a structure. So now we'll see in details one by one each category. So first one we'll see is that first we'll discuss how actually loads are transmitted from top to bottom. So just here I'll demonstrate. So here if you see a frame of a structure, so at the frame here at the top you have a roof. So this is your roof. So from roof, maybe if you consider this as a second story, two-story building, then what will happen is those who will stay in the two-story, so human are resting on a floor. So one person is standing here, another person is standing here, maybe some bed is here. So all the loads are actually coming to this slab. So first load, whatever load is there, dead live load basically, will transfer to the slab. Now the slab is resting on these two beams. So this is one beam, this is another beam, this is another beam, this is another beam. So four beams are there. So our slab is resting on a beam. So now load whatever human or live loads are there. So that load from slab it will be transferred to the beam. Now see, beams are actually connected. All beams are connected through columns. So see, these columns are there, four columns. So now from load will transfer from beam to column. and then column to foundation. So this is the basic load path, normally we call it. So live load is basically resting on a slab. So load will go from slab to beam, then beam to column, and then column to foundation. So that is a typical load path of a structure. So whatever we have discussed in this previous slide was basically a vertical load, but your structure may be experiencing as a horizontal load also, like wind load we discussed in the last slide. So wind load is basically the horizontal load. So because of horizontal load, so your structure, so some these bracings also you need to provide. If your structure is situated in a heavy wind areas, then you have to provide extra precaution for the wind as well. So these bracings are normally provided to take care the horizontal force. So you can see this is right side structure where this horizontal these bracings are provided to take care the horizontal force. So when this structure is subjected to a horizontal load, so this bracings will take care the portion of the horizontal load, and it will resist the load. So now if you see, as we discussed in the previous slide, the load path means the load from slab, it will go to beam to column, and then column to foundation. That is a typical load path. So now how much portion of the load will transfer from slab to beam? So now that is the next question we will try to address in this slide. So if you consider, if you see, this is a slab, so it is a square slab. So how much, so people are standing here, maybe some furnitures are also there, TV, fridge, many things may be there in this floor. People are also standing. So now how much load will go to this beam, how much load will go to this beam, how much will go to this, and how much will go to this? How do you calculate? So if it is a square beam, then you just make a two diagonal lines, and this portion of the load, whatever is load is there from this portion, will transfer to this beam. This portion of load will transfer to this beam, and then it will continue. So this portion of load will transfer to this, and this area load will transfer to this. So that is a typical load path for a slab. Now if your slab is rectangular, then what will you do? Then if it is rectangular, then we have to draw a 45-degree line from both the sides, and this portion of the load will go to this beam. So this portion of the load will go to this beam. Then you have here, you have a trapezoidal shape. So this portion of the load will go to this, and similarly this portion of load will go to this beam. So that's how the load is distributed from slab to beam. So if it is a rectangular, if it is square slab, then all four portion will be going for in the four respective beams. But whereas if it is a rectangular slab, then you have to divide the entire structure, entire slab into these four portions. You have to draw 45-degree line here, 45-degree line here, and then joining line. And this is a trapezoidal load will come here. This rectangular load will go here. Similarly, trapezoidal will go here, rectangular will go here. So that's how the load is actually transferred from slab to beam. So if you consider this one now, so here this beam is actually this is the type of loading this beam will experience. So this middle portion will have trapezoid. So this is a rectangular shape. No? This is the rectangular shape. It will affect like that. But in case of trapezoidal case, the beam will experience the load in this manner. So now we'll discuss the different loads as we mentioned in the first slide. So dead load, already I have mentioned the dead load is the self weight of the load. So see if you, this is a beam, and beam has some its own weight. So that low weight is acting downward. So that weight we call it dead load. So dead load is basically nothing but the weight of the structure itself. So self weight of the structure we call it dead load. So how to calculate the dead load of a structure? So structure is made up of either maybe concrete or steel or whatever may be the material structure is made up of. So if it is a aluminum, then you know the density of the aluminum, and you can calculate what is the volume of each material. Then immediately you can find it out how much is the weight, that is self weight. Similarly, if it is a concrete, then you know how much is the density of the concrete. It is almost 23, 24. kilonewton per meter cube. So you calculate how much volume of concrete is here, then you multiply it with the density, you will get how much kilonewton force is there, kilonewton load is there of this beam. So like that, using the standard table, material table, you can compute what is the entire load or self weight of the structure. Now, as already I mentioned, live load is basically what which is movable load. So in a building, so this is a structure building where this all the humans load is basically the live load, and all the furniture, if you see bed and a TV, fridge, almirah, everything's load is other than the structure's load, we call it is a live load. So live load also you can compute. So for example, if you are designing a hospital structure, then you can consider the live load as a 1.92 kilopascal. So these are the some values, fixed values are there. For example, if you are designing a school load, then how much live load it will consider. So some standard values are available. Just consider that value and you design your structure. You analyze your structure. So for different category of buildings, different types of loads are available. Already this chart is available. So this you can consult and directly you can put the values in respective locations. So next we saw is wind load. So wind load is very much dominant if the structure is lying above a hilltop or somewhere, or maybe near the coastal region where the wind speed is significantly high. So but in other case we may not consider the wind load. So this is the wind load map of India. So if you can see different parts of the India, different values will be there. So here maybe some wind value, but in here in Andhra Pradesh, Bangalore, some other value will be there. In Northeast, some other wind value will be there. So this map is prepared from last 50 years data they have considered, and they prepared a map of India. So whenever you construct a building in maybe Bihar, so you have to take whatever wind speed is there in the Bihar. If you construct a building maybe in Andhra Pradesh, AP here, you have to construct whatever the values are there. Normally wind speed in Andhra Pradesh, that value you have to consider, and you have to design a structure. So that's about the wind load. And lastly, we have discussed is important load is earthquake load. So because of earthquake is nothing but a shaking of ground. So once grounds are shaking, so because of this shaking, our structure experiences a extra load, and because of this load, our structure collapses in some situation. So how to calculate how much is the earthquake load is basically our so you can see this is a seismic zone map of our India. So this red color is basically the zone 5, means these areas are more prone to earthquake. So when you construct, if you construct a building in northeast, these locations, these are entirely, if you construct here maybe in this northeast area, then it is a zone 5. So you have to consider the earthquake load definitely to construct or to design a building in the northeast area. But if you see compared to the northeast, other South India is little bit stable, so there is very less earthquake you will find in this region of India, whereas in North India also you will see there is a zone 4 or zone 5 in some locations, but in South India it is little bit stable, there is very less earthquake in this region. So so whenever you construct a building maybe in different locations of India, you have to consider what is the earthquake value from this table, and that value you have to incorporate, and you have to design or you have to analyze the structure. So lastly, we'll discuss about what is load combination. So in last three four slide, we have discussed dead load, and then we have discussed live load, and then we have discussed wind load, and then we have discussed earthquake load. So, but now the question is, for analyzing a structure, whether we'll take all the loads or not. See, maybe some area, maybe near to the coastal area, and which is subjected to wind load. But these area may not be subjected to earthquake load. For example, if you take to consider of Andhra Pradesh, it is coastal state, right? So here you have to wind load. You may have to consider because wind speed will be more near to the coastal region. But the Andhra Pradesh is very less prone to earthquake. So you may not consider earthquake load while designing a structure in the Andhra Pradesh. So now, which load will you take? So to design a structure in Andhra Pradesh, you will give more focus to the wind load compared to the earthquake load. So based on that, our Indian code has given some guidelines to design. So these are the different load combinations you will consider, and you will find out every all the cases, what are the final value. So dead load 1.5 dead load plus 1.5 live load, whatever is the value comes. 1.5 dead load plus 1.5 live wind load, whatever value comes. So like that you compute all the values, and whichever is the highest maximum load you will get, that you will take for your structural analysis of that particular building. So that's how actually it goes. So you have to analyze, you have to find it out all the different possible load combinations, because in some locations snow, because maybe this is very high in high altitude, so there may be snow load, but there may not be wind load, or there may not be earthquake load. So it is not wise if you consider all the loads in a particular location. So that's why you have to use perfect combination of loads. So our code has given different combinations of loads, so we have to compute each combination values, and then whichever is greater value we will get, that only we will use for our analysis.